My name is Haseeb Khan, and today I'll be showcasing a demo for my thesis project, Active 458, called CNC Handwriting Machine. As you can see, this is a 3D printed pen mount, which is powered by a servo motor. Now we'll move on to the connection setup. This is a CNC shield which sits on top of an Arduino Uno. It houses the two A498 motor drivers, the servo motor connections, and the stepper motor connections. As we can see, that's the x-axis and that's the y-axis. This over here is the y-axis stepper motor, and this is the x-axis stepper motor. Next up, we'll move on to the software aspects of the machine.
There are three main aspects when it comes to the software: sending the global code using Arduino IDE, generating G-code using Inkscape, and sending the G-code to the CNC handwriting machine using Universal G-code Sender. In this section, we'll explore how to do each thing. Firstly, we'll send the global code to the CNC handwriting machine using Arduino IDE. The global code contains general CNC machine settings. As you can see, I've already done that by clicking on the upload button. Next up, we'll create a simple design in Inkscape. We'll create a square and a star. Select both of the images, path, object to path, extensions for XI draw tools, generate pen geocode tool. We'll leave the settings as they are. We'll name the file shapes demo and put it in the sketches folder. Click on apply. Once that is done, it will look something like this. We'll navigate to our actual file to see what G-code looks like. This is what a G-code looks like. You have the G, which stands for the G-code, the feed rate, the X coordinate, the Y coordinate, the speed at what it moves, and M3 indicates when the pen goes down, M5 indicates when the pen goes up. Now we'll send this G-code file to our Arduino CNC shield and our CNC handwriting machine using Universal G-code Sender. We'll open up Universal G-code Sender, we'll navigate to our file, Shapes Demo, click on Open. As we can see, this is our design. Now, to make sure some settings are correct, we'll have a look at this bit. The firmware needs to be global, your correct COM port needs to be selected, and the correct baud rate needs to be selected. We'll click on this connect button. Once that is done, that means we are now connected to our CNC handwriting machine. If that says idle, that means we are actually connected. To send the design to our CNC handwriting machine, we need to click on Run, which we'll do next.
After clicking on the send button, the machine will start drawing. As you can see, the machine draws our design of the star and then the square. Next up is a compilation of some of the complex design drawn by the CNC handwriting machine.
As part of the results section, a small test was conducted to determine the maximum rate at which the x-axis and y-axis could travel while focusing on the accuracy. A set of 2 cm lines were drawn with a 1 cm interval between each line. This will determine how fast the pen can move up and down while maintaining speed and accuracy. As we can see, at the rate of 3,250 mm per minute, the results are starting to get affected in terms of line visibility. And this is because the pen is moving up and down so fast that there's no constant pressure to keep the pen pressed, which causes the line to fade. This action is exactly like a human is writing. If the pen is putting constant pressure on the pen, the line will be visible, but as we start to alleviate that pressure, the line becomes lighter and lighter. The point at which the accuracy is compromised is 10,000 mm per minute, so the correct rate to use for the CNC handwriting machine would be 3,000 mm per minute. This is the poster for the CNC handwriting machine. It contains the abstract, CNC machine itself, design process, which contains the 3D printed pen mount, the circuitry, and the results and analysis, and some designs which have been created by the CNC handwriting machine.